Hey class, Miss Hamilton here. So video lesson 2 today is 2.2 length of a line segment. So we just looked at finding the middle, but what if we want to find the actual length of the line segment? So for example, if we were to look at the following line G and H here, and we've graphed them for you, when we're kind of looking at it, what we're looking at is we're looking at the distance that the x's traveled and the y's traveled. So we would have a difference here, we would have a difference here. So what we have forming here is a right angle triangle. And if we can find a value here and we can find a value here, thus we can solve for the c value because essentially it's just the hypotenuse. Okay, so kind of relating back to a squared plus b squared equals c squared. And that's how we've essentially developed a formula to solve for the length of a line segment. So the length of a line segment is given with any 2 points. So as I always recommend, I would label your points x1, y1, x2, y2. And then I tend to say follow this formula here, okay? Because it's already incorporating the square root for you. So where we find the differences between the x values and square, and we find the differences between the y values and we square. Okay. Again, you could use the other formula. I just find this one right away gives you the answer. Okay. And I recommend writing it fully down before doing that. So let's take an example. Let's look at an example of a line segment, and let's do one together. So flipping to example 2 here. So find the length of a line segment. Give an exact answer and a rounded answer to 1 decimal place. Okay. So if we want to, what we could do is we're just going to write the formula down. So we're going to say we're trying to find the line segment length of mn. We know the formula is the difference between x2 minus x1 squared, okay, plus the difference of y2 minus y1 squared. And as I recommend, I would label your coordinate points so it just makes it a little bit easier when you plug that in. Okay. So what we're going to do now is you're just going to plug those values into the formula. So x2 is 10, okay, subtract -2. So just remember, put the subtraction, put the -2. If you'd like to convert it right away, go for that. I'm fine with it, but don't make mistakes with the 2 negative values. Plus -5 minus -3 squared. Okay, so what we do now is we solve for what's in the brackets. So we get 10 minus -2, which ends up becoming 12 squared, plus -5 plus 3, which is -2 squared. Please don't make mistakes when you're squaring these values. Remember, -2, because it's in brackets, means you include the negative when you're doing the operation, okay? So please don't make those errors. So 12 squared is 144. -2 squared becomes +4. Okay. So continuing on, we get the square root of 148. Thus, our answer is 12.2 units. So using that formula, we've been able just to solve for the units, okay, length of a line segment. Now, when will this come in handy is when we're trying to identify figures, and that's where we'll be going next week with this. So we're going to do an example of how to identify either a scalene, isosceles, or equilateral triangle, okay, using this idea of line segments. So moving on to example 3. So in example 3, what we have is we're giving, I'm going to make this a little bigger, so D, E, and F. And we're given the coordinate points of this triangle, but we want to find out if this triangle is an equilateral, an isosceles, or a scalene. Okay, so again, equilateral, all 3 side lengths are the same. Okay, isosceles, 2 side lengths are the same. scaling, all three side lengths are different. Okay, so what we're going to do is we're going to solve for the value of each of the side lengths. So I'm going to do an example, and then I'm going to have you guys try a couple yourself. So what we're going to do is we're going to start with side length DE. And I find the best way to label it is just to label it D to E. Okay? And then we're going to plug in the values. Okay? So I'm just going to move over so I can see the values. So again, we're going to start with the x's. So we're going to say -2, okay, subtract -8, and that's all squared, plus 4, subtract -4 squared. DE. So then you're going to solve underneath. So -2 plus 8 gives us a value of 6 squared. Okay. Plus 4 plus -4 gives us a value of 8. And 8 squared. Okay. So once we do that math out, we get D equals, okay, the square root of 100, which gives us a value of 10 units. So we have found out that the length here is 10. Okay. Now what we're going to do, I'll change colors. We're going to look from E to F. Okay, so we're going to look from E to F now. So again, we're going to go E to F. And we start with the second value. So we're going to start with S value. So we're going to start with the 4, subtract -2 squared, plus -6, subtract 4 squared. Again, continue to label on. I would say take your time when you're solving this too. Don't try to rush and skip too many steps ahead, because that's when you're going to make this mistake. So again, 4 plus 2 is 6 squared, plus -6 minus 4 is -10 squared. So again, just take note of that negative, right? -10 times -10 is 100. So please don't make a mistake with that. Okay? So we would end up getting 36 plus 100 here underneath. So we get 136. The square root of 136 is approximately, we're going to go to one decimal place, 11.7 units. So we found that 11.7 exists here. So what I'm going to do at this point, I would like you to pause the video and attempt to do F to D by yourself here. Okay? So take a second to try that by yourself. So solving for FD. Okay? So we're going to start with the x values first. We're going to go -8, subtract 4 squared, plus -4, subtract -6 squared. So I solve what's underneath the square root. So -8 subtract 4 is -12 squared. So again, note the negative. Okay, and then -4 plus 6 squared is 2 squared. Just going to move up a little bit just so we can get this all in. So we end up getting FD equals the square root of 12 squared is 144, okay, plus 2 squared, which is 148. And we already know from the previous question that 148 squared is 12.2 units. So what we can confirm now is if this is 12.2 units, okay, is that we can confirm that this triangle is a scalene because none of the sides are alike. So it's a scalene triangle, okay? Because none of the sides are alike. And we're going to even take this one step further starting on Monday because we're going to be looking at the different types of triangles once we get going with it. Okay, a little bit further. So let's look at an example where we're using midpoint and we're using the length of a side length of a line segment to solve. So incorporating the two lessons from today into one question. So example 3 is asking you to find the length of a line segment called XY, where X and Y are the midpoints of DE and at DF. So again, we have this triangle, okay? So I'm just gonna label the points. It's the same triangle as last time. So we have D, E, and F. So what they're saying is we're creating these two new points called X and Y, okay? But X and Y are the midpoints of DE and DF. So let's find the midpoint of DE, okay? Which is going to be labeled X eventually, okay? Because that's going to be our new coordinate, X. So when we go about this, we would take D and E and add their X's together. So -8 and -2 would be added together. So -8 plus -2 divided by 2. So that would be the X coordinate, and then our Y coordinate, so again, this is a comma here, okay, would be -4 plus 4 divided by 2. So we find out that this X coordinate, okay, that we want to find the midpoint, we're relabeled, exists at -5 and 0. So if we want to, we would graph that point, so -5 and 0. So we're going to label that X now, okay? Now what we're going to do is we're going to do the midpoint of DF. And we're going to label that one Y. Okay? So again, we start with the X coordinates of D and F. So we would have -8, okay, plus 4 divided by 2. That's our X, and then comma, we'll look at the Y's, -4 plus -6, okay, divided by 2. And we find out, so we're going to label this Y, okay, that we get -2 and -5 as our point. So we can graph that, so -2, -5, and that's our Y coordinate. So what we have now is we have these two new points. I'm just going to highlight them. So those are our two new points. And what they want to do is they want to find the length between those points. Okay? So lucky for us, we have a formula to solve for that. Again, we have X, Y, a line segment. And what we're going to do is we're going to use that formula. So I'm just going to bring it back up. So just right here. Now to solve for that. So let's use those points. Okay? So the differences in our X points is what we're looking at. So let's start there. So -2 subtract -5 squared plus, now we look at the Y's. Okay? We would go -5 subtract 0 squared. So we get -2 plus 5 leaves us with 3 squared. And then -5 minus 0 leaves us with -5 squared. So -3 squared is 9. -5 squared is 25. We add those together. We get 36. And just don't forget to square root your question. So some people forget the square rooting, okay? So XY in this situation equals 6 units. So I think that's a really good question because what it does, it incorporates your midpoints, okay? but then it incorporates the length of a line segment, and that's why I want to do those two lessons together. Again, you'll have a homework day tomorrow to work through it because I understand that it is a lot of homework and I don't expect you to get that all done in one day. So here's the homework for this lesson right here. Okay guys, have a great rest of the day. Bye.